so the good news is I'm not going to make you use that limit definition to find a derivative value until much later in the year when we're doing review for the AP exam. So starting today, I'm going to let you use shortcuts, right, to find the derivatives. Okay, and so here they are. Here's a couple simple derivative rules. Number one, again, you should know how to read this, you guys. This says take the derivative of whatever follows with respect to x. And so you're taking the derivative of c, which again, I always said is going to be a constant. So the derivative of a constant is what? 0. Okay, now this is the power rule. This is the one you're going to use most often to find a derivative. Okay, so to take the derivative with respect to x of something in the form x to a power n, it's real simple. Okay, you bring down the exponent, you multiply it out front, and then subtract 1 from the exponent. Again, make sure you bring it down first, multiply it out front, and then subtract 1 from the exponent. Okay, that's the power rule for derivatives. Okay, so here are some examples. How do I take the derivative of that? Well, again, notice how I note I'm taking the derivative there. And so the derivative of that is what? Well, you bring down the exponent, multiply it out front, subtract 1 from the exponent. Got it? That's a derivative. So all that work you did with all those limit steps can now be avoided, right? And just go right to the derivative in one step. All right, what's the derivative of 6? Well, derivative of constant is what? 0. Okay, take the derivative of that again. You just bring down the exponent, subtract 1 from the exponent. And again, notice how I indicate I'm taking the derivative by putting a little y prime. Okay? And here's another way I can indicate I'm taking the derivative of that by just saying the derivative of y with respect to t is, well, what's the derivative of that? What's the derivative of that? 4. Right? Just bring down the exponent, multiply it out front, subtract 1 from the exponent. Okay? The derivative of that is what? 3r squared. All right, now this simple one can be tricky. How do I take the derivative of plain old x? Well, you can think of it as x to the first, can't you? Right? So then when you bring down the exponent, multiply it out front, subtract 1 from the exponent, you get that. But anything to the 0 power is what? 1. And so you just end up with what? 1. Okay, does that make sense? So the derivative of x is 1. Okay? All right. Now sometimes we need to write things using algebra, okay, before you can actually apply a derivative rule. So for example, look at this. Is this in the form where you can directly use the power rule? No, it is not. Okay? Because the x is in the denominator of a fraction. There's no rule for that. So how can I change that into something where I can then apply the derivative rules? Well, from Algebra 1, didn't you learn that that's the same as 1 over x to the first, and then you can bring that up top if you want by just making a negative 1 exponent, right? So again, I did not take the derivative yet. All I did is rewrite it. It's still f of x, isn't it? I did not take the derivative yet. All right, are you with me on that? Okay, now is it in a form where I can use the power rule? Yes, it is. So here we go. So to take the derivative of that using the power rule, I bring down the exponent, multiply it out front, and then subtract 1 from the exponent, giving me that right there. Now I'm going to say something, and please don't forget this. This goes for the homework, and this goes for the test. Never leave a negative exponent in your answer. Never leave a fractional exponent in your answer. So am I going to leave my answer like that? No, I'm not. So how do I make that a positive exponent? By moving that where? To the bottom. Okay, and then you can make it a positive exponent. Okay, so again, that last step from here to here was just algebra, wasn't it? Okay. All right, is this in the form where I can use my power rule? No, it is not. But again, in Algebra 1, you learned that you can rewrite that as x to the half. Now is it in the form where I can use the power rule? Yes, it is. So here we go. To take the derivative then, by marking y prime, I can bring down the exponent, multiply it out front, subtract 1 from the exponent. And again, am I going to leave my answer with a negative or a fractional exponent? No, I'm not. So the first thing I want to do to my answer is what? Move this to the bottom and make it a positive exponent. Am I going to leave my answer like that? No, never leave a fractional exponent in your answer. So how can I change that? X to the half. I can change it to what? Square root. So that's what I want your answers to look like. You guys, I think the book, if you check the answers in the back, they might leave it like that, but I don't want you to. Is that clear? So if and when I check this homework, you don't want to have your answer like that because you're not going to get full credit. So if I were to check this problem on a homework assignment, I would want to see that answer and nothing else. Is that clear? Even if the book answers leave it like that, I want you to keep going as I'm showing you right now, okay? Remember that. Clear? Okay, keep going. All right, is this in a form where I can take the derivative right away? No. Now, yes, wait a minute, wait. I know the mistake you're going to make on this. You're going to say, oh, I'm just going to take the derivative of the top over the derivative of the bottom. There's no such rule. So please don't think like that, okay? So the bottom line is you cannot take the derivative the way it is. So who's got an idea what I can do to rewrite it into something I can take the derivative of? Go ahead. Yep. Okay, so before you do anything, you can write it like that, right? Just using algebra, right? Now it's in the form where I can use the power rule. So this is a step where I'm going to say the derivative f prime of x equals what? What is it, guys? -2, right? You bring down the exponent, multiply it out front, and then subtract 1 from the exponent. It's giving me what? -3. Am I going to leave my answer like that? No, I'm not. And so how do I make that a positive exponent? By moving it where? To the bottom. Am I going to move the -2 as well? No. That's another mistake that I see students make. There's no reason to move the -2. It's not raised to a negative exponent. Let's leave the -2 alone. Is that clear? The only thing you're moving is that, so you can make it a positive exponent. Got it? Yes? Okay. So guess what one of the wrong answer choices is going to be if this were a test question? Guess what one of the wrong answer choices is going to be? Yeah, the -2 on the bottom. So don't go falling for that. Got it? Okay. All right, everybody try D. Give it a shot. Remember, never leave a negative exponent in your answer. Never leave a fractional exponent in your answer. So do whatever algebra you have to do to take care of that. Write small if you're not already, because otherwise you're not going to fit. Okay. You tell me, guys, what do I write it as first? X to the what? 2/3. Now it's in a form where I can use the power rule for derivatives. So this is a step where I'm taking the derivative, right? Okay, to take the derivative of that, I bring down the exponent, multiply it out front, and then subtract 1 from the exponent. What's 2/3 minus 1? -1/3. Am I going to leave my answer like that? No, I'm not. I'm going to move that to the bottom to make it a positive exponent. Everybody agree it should look like that? Am I going to leave that as my answer? No, I'm not. I'm going to change that to what? The cube root of x. So, on the homework tonight and on the tests, I would want nothing but that answer. Is that clear? And please make sure that fraction bar is long enough so that it's clearly in the bottom. A lot of times I see answers like this, and I don't know where that is. Is that in the bottom? I can't really tell. So don't be shorting me on your fraction bars. Is that clear? Right? Okay. And by the way, please do this as well. Because if you show me nothing but this, I'm not going to know what step is the derivative and what step is the regular function. Got it? So make sure you label at least the step where you're taking the derivative. Got it? Okay. All right, more derivative rules. Ready? What are they? What does this one say? When you're taking the derivative and you have a constant times a function, what can you do with that constant? Pull it out before you take the derivative. If you don't do that, then every one of these derivatives is going to end up being what? 0. Because you're going to say, oh, I'm taking the derivative of a constant. No, you're not. You're taking the constant out. And then you're taking the derivative of the rest of it, and then you're multiplying by the constant at the end. Do you understand what I'm saying? If you leave the constant in there, you're going to say the derivative of a constant is 0, then you're always going to get 0, which is not correct. Do you understand what I'm saying? So pull the constant out, and then take the derivative, and then multiply by the constant at the end. Okay, what does this say? If you have a sum or difference, you can what? Take the derivative of each term separately and then just add the derivatives at the end. Same thing with a what? A difference. Do you see any rule for a quotient or a product? No, because there is none. So don't go making up your own rules. Right? There's no derivative rule that says you can split up the derivative of a product into separate derivatives. You cannot. Got it? Same thing with a fraction. There's no rule that says when you have a derivative of a fraction, you can take the derivative of the top over the derivative of the bottom. That doesn't work. So don't go making up your own rules. You can only take the derivative separately for a what? A sum or a difference. And that is it. You understand? Okay, moving on then. Real quick then. This means take the derivative, doesn't it? What am I taking the derivative of? 6x to the fourth. So, again, notice what I did. I pulled out the 6. I'm going to take the derivative of the rest of it. What's the derivative of x to the fourth, guys? 4x. Thank you. 4x to the third. And then you're going to multiply by the 6 at the end, giving you a final answer of that. You see what I was saying? Because if you leave the 6 in there, you're going to want to take the derivative of the 6, which is 0, and then 0 times the rest of it's always going to give you 0, isn't it? That's not right. The only time the derivative is 0 is when it's just what? Taking the derivative of a what? Constant by itself. Is that clear? Yes? Okay. All right, so get B. Again, you don't have to show the step. Basically, just leave the 4 alone and then multiply by the derivative of x cubed, which is what? What is it? 3x squared. And so your final answer is that. Got it? All right, again, here, what did I do? I took out the what? Took out the 5, and I take the derivative of x. Now, again, how do I take the derivative of x? Well, I think of x as x to the first. So I bring down the exponent, subtract 1 from the exponent, giving me that. And then x to the 0 is 1. And so what do I get for my final answer? 5. All right, now hold on a minute. That was a lot of work. What's the shortcut? What's the shortcut there, guys? What's the derivative of 5x? It's just what? 5. So what's the derivative of 7x? 7. What's the derivative of negative 3x? Negative 3. What's the derivative of 85x? 85. Got it? Okay? All right. So again, what's the derivative of 2x? 2. What's the derivative of negative 3x? Negative 3. What's the derivative of negative x? Well, you can think of that as negative 1x. So what's the derivative of negative 1x? Negative 1. Are you following me on this? Okay? All right, so here, without doing all the steps, you can do it in one step. To take the derivative of that, I just take the derivative of the 4x cubed, right? I'm sorry, let me say that again. I take the derivative of x to the fourth by bringing down the exponent, multiplying it out front, giving you what? 8. And then subtract 1 from the exponent, giving me that. And then what's the derivative of 10x? 10. So you see how you can do that now in one step without showing all the in-between work, right? Good? All right, everybody do the next 2. Go. Okay, these two problems should take you about 10 seconds each, and that's about it. So you should be done. Ready? Okay, Paige, what's this one? Quick. Okay, good. All right, next one, Jason, what's this one? Okay, good. All right, we good on this? Okay, so polynomials, once you get the hang of it, are not too bad. All right, so a new derivative rule. The easiest one that exists. What's the derivative of e to the x? E to the x. Can't get any easier than that, right? The derivative of e to the x is just e to the x. So, keep that in mind when you run into something like that. All right, now again, as I said a minute ago, you cannot what? You can't just take the derivative of the top over the derivative of the bottom. There's no such rule. That does not work. So, we got to do something else first, right? Let's do a lot of Algebra 1. And I'm going to do it on separate paper so I don't have to cram it in there. So you're going to have to write kind of small, though, to fit it in. Ready, guys? All right. Isn't there an Algebra 1 rule that you use, like when you're changing the slope-intercept form, for example? That when you have a sum or difference on top and one term on the bottom, you can split it up into the a over the c plus the b over the c? And that works for a difference as well, doesn't it? So can I split this up before I do anything? Yes. What can I split it up into using Algebra 1? Into what? Square root of x over what? X plus x squared over x. Now hold on, there's more I can do here. And can I write that as x to the half over x to the first? Same thing here, right? This is all Algebra 1. This is all still f of x, isn't it? Okay, is there an Algebra 1 rule that allows you to combine those? Is there? Yes. What's the rule? What's the Algebra 1 rule that allows you to combine those into one term or one thing? Yeah, you subtract the exponents from top to bottom, right? So what's a half minus 1, guys? Negative a half. Same thing here. You can write it as x to the 2 minus 1 power, which is x to the what? First. Okay. Have I done any calculus yet? Nope, that's all Algebra 1, isn't it? Okay, now, is this in a form where I can use the rules I taught you today to take the derivative? Is it? Yeah, so this is a step where you say, okay, the derivative f prime of x equals, and again, just use the power rule. Bring down the exponent, multiply it out front, subtract 1 from the exponent. Everybody agree that negative a half minus 1 is negative 3 halves? Isn't it? Okay, and then what's the derivative of x, guys? 1. Again, because you can think of that as 1x, and the derivative of 1x is just 1, right? Got it? All right. Am I going to leave my answer like that, even if the book leaves it like that? No, I'm not. I'm going to keep going. So what am I going to do? First of all, I'm going to make that a positive exponent by what? Yeah, bringing this whole thing to the bottom. So it's going to give me this. Right? Everybody agree? Am I going to leave my answer like that? No, I am not. I'm going to change this to what? Radical form by writing it as what? Square root of x cubed. Am I going to leave my answer like that? No, why not? Because when the exponent is bigger than the root, you can simplify further, can't you? Remember that from the summer packet? So off to the side, I want to make these match. So I'm going to write x cubed as what? X squared and times what's left over. X to the what? To the what? First. And I'm going to split that up into what? Square root of x squared times the square root of x. And this just turns into what? X. Okay. So off to the side, I did some more algebra. Now, if I wanted to, I could go one more step. I'm not going to, but if I wanted to, what's one more step I could do there? Get a common denominator. Well, wait. Good question. Do I need to get rid of the radical in the denominator? No. When there's a variable, you can leave the radical in the denominator when there's a variable inside. The other thing I was going to say, though, is I could get a common denominator. How would I get a common denominator if I wanted to? Multiply this one by what? By what? 2x squared of x over 2x squared of x. I might want to do that eventually, just not today. Okay, but again, you don't need to get rid of the radical in the denominator if it contains a variable. So for right now, I'm okay with you stopping right there. So that's what I would want that answer to look like if that was a homework question, regardless of where they stop in the back of the book when you check your answers, okay? Any questions? Okay, moving right along, let's go to B. Okay, what's B? Okay, ready? All right, so to take the derivative of that, I can just like pull out the 3, just leave it alone, and then multiply by the derivative e to the x. What's the derivative e to the x? E to the x. Now, is that the same as e to the x? No, it isn't. But isn't e just a number? Isn't e like 2.7? So can't I just take the derivative of that just like I would take the derivative of x squared or x cubed or x to the 4th? So wouldn't I use the power rule on that one? By bringing down the exponent, multiplying it out front, and then subtracting 1 from the exponent? Do you see how that's different? Everybody agree that x to the e is not the same as e to the x? Okay? And then what's the derivative of that? 6. And there's not a whole lot more you can do there, so that was one step. Any questions on that one? Okay, well just stop me if you have any questions. Let's keep going. Let's look at C. All right, so, ready? All right, well, this one's ready to take the derivative of, but is this ready to take the derivative of? No. Wouldn't I have to get that written in a different form in order to take the derivative of it? And so, how can I rewrite that, guys, as what? 2/5 times either on top or off to the side, x to the what? Negative 1/3. Okay, isn't that the same thing using Algebra 1? Again, I have not taken the derivative yet, have I? That's just Algebra 1, isn't it? Rewriting it like that? Okay, now is it ready to take the derivative? Yes, it is. So here we go. The derivative f prime of x is equal to what? What's the derivative e to the x, guys? E to the x. Here, I'm just going to use the power rule by bringing down the exponent, multiplying it out front, and then subtracting 1 from the exponent. Okay? Didn't I just use the power rule there, right? All right, now I got a lot of algebra to do, right, to simplify that? Okay, so here it goes. First of all, minus and negative turns into a plus. When I multiply those, I get what, 2/15, right? And then to make that a positive exponent, don't I move it to the denominator? Right? Everybody okay with that? I don't stop there though, do I? No. Okay, so I'm going to change that to what? You tell me. What am I going to change the x to the 4/3 to? To what? Well, I'm going to first change it to what? The cube root of x to the what? 4th. Is that something I can simplify or not? Yes, it is. So I write it as many powers of 3 as I can, which would leave me with x to the 1st left over. And we'll split it up into that times that, which is just x cubed root of x. Isn't it, guys? And again, if I really wanted to, I could get a common denominator, but I'm not going to. So we'll just stop there. Okay, guys? Good? Okay. All right. All right, like I said, don't go making up your own derivative rules. Is there a rule that lets me take the derivative of a product right now? No, there is not. So you cannot take the derivative the way it is. So what are you going to do instead? You're going to what? Distribute before you do any calculus, right? So you can distribute like this, right? Now, can I take the derivative? Yes, I can. So everybody, what's the derivative real quick? What is it? 4x minus 5. Okay? Okay, let's look at example 5. Okay, find an equation of the tangent line. Ready, guys? For that function at the point where x is 2. So we're talking about the point 2 comma what? What do I get when I put a 2 in there? What do you get? 2 comma what? 1. You guys, please. Shh. Okay. All right, now. How are you going to take the derivative of that? Is that in the form where you can take the derivative? No, it is not. Don't go making up your own rules for that either. So what should I do to that to turn it into something I can take the derivative of? FOIL. So what do I get when I FOIL? X squared minus 2x plus 1, right? Now I can take the derivative. Agreed? Okay, so here we go. Everybody agree the derivative is what? 2x minus 2, is that right? Okay. But now I want to find the what? The equation of the tangent line. So at the point 2 comma 1, what's the slope? Well, don't I just plug the x value in there to get the derivative or slope? Yes? And so what does it equal, guys? 2. So at the point 2, 1, the derivative or slope of the tangent line is 2. Does everybody agree? But they didn't just ask for the slope of the tangent line, they asked for the equation of the tangent line. So what am I going to do now? Use the point slope form to write the equation of the tangent line. So what is it? Y minus 1 equals, I'm just using this and this now, aren't I? Right? Equals 2 times the quantity what? X minus 2. And if you want, you could change it to slope-intercept form, in which I'm going to go ahead and do right now. And what do you get? You get that for the equation of the tangent line in slope-intercept form. All right, what do they want you to do in part B here? I want you to what? Yep. I want you to graph what? The original function and the tangent line to see what's going on. Okay, so here it goes. Okay, if I did this correctly, what should I be looking at when I graph in a second? I should be looking at a tangent line at the point what? 2 comma 1 on the original graph, right? Are you ready? Okay, so I'm going to hit zoom Z decimal. Let's try that window. There's my original function. Does it look like I have a tangent line at the point 2, 1? Does it? Yes, it does. So I know I did it correctly. Okay, good? Good? All right. Let's look at example 6. I'll tell you right now, guys, I mean, all these questions here and all these examples are typical AP questions. So obviously they're going to be typical questions on my test as well, right? So you can see every one of these examples is different. And so you're going to have to know how to do all these different situations on the next test, right? So again, if you guys study my notes, you know, that should be the vast majority of your studying, because that's, you know, mostly the stuff that I focus on, right, on my tests. Okay, so there's one like this on my notes. There's going to be one like it on the test, guaranteed. Okay, so here it goes. Ready? All right, so what am I trying to do? Well, find the points where you have a horizontal tangent line. Ready? Okay. Okay, so horizontal tangent means what? Slope is 0. So in other words, the derivative equals 0. Everybody agree? So when it talks about horizontal tangent lines, think derivative equaling 0, right? Got it? Okay. So with that in mind, here we go. So what is the derivative, guys? 4x cubed, yes. Minus 12x, is that it? Okay, now I want to figure out where that derivative equals what? 0. So set it equal to what? 0. And then solve for x, right? And what that will do is that will give you the x values of the points on the original graph where you'd have a horizontal tangent line, right? Got it? So here it goes. How do I solve that for x? Well, what can I pull out? A 4 and an x, leaving me with what? X squared minus 3. Okay, so now that you got a product equaling 0, this is more algebra 1, can't you just say that product will be 0 when that's 0 or when that's 0? Can't you? Okay, so doing that, what do I get, guys? Here x is what? 0, here x is what? Plus or minus square root of 3? Okay, now sometimes it'll just ask you for the x values of the points on the original curve where you'd have a horizontal tangent line. If that was the case, I'd be done. But they didn't ask me for just the x values of the points. It asked me for the what? The points. So what do I got to do? Write these as what? Ordered pairs, right? And by the way, where am I plugging these x values into to get the y values? Into the original equation. So if I plug 0 into the original equation, what do I get? 4. Okay, this one's going to be tricky. What do I get when I plug square root of 3 into the original equation? Well, let's see. I'm going to write this as 3 to the what? 4 halves, which is 3 squared, which is what? 9 minus what? 18 plus 4. Everybody see what I did there? Yes? So what is that, guys? Negative 5? And by the way, this will be the same thing if you do the math. Okay. Everybody see what I did there? I just wrote that as, got creative and wrote it as 3 to the 4 halves, right? Which is 3 squared, which is 9, right? Okay. All right, so what are these? These are what? The points on the original curve where you'd have a what? Horizontal tangent line. By the way, you guys should know what square root of 3 is roughly. What is square root of 3 roughly? 1.7? Okay, so what I'm saying is, if I graph the original function, oh, that's a derivative. I don't want to do that. I'm going to graph the original function, right? Sorry about that. So here's the original function. Man. What's it doing? Okay, there we go. All right, so there's that. And then from the graph by hitting, let's just hit zoom, Z, I like the decimal window. Maybe not in this case. Let's go with the standard window. Okay, so what do you think? Does it look like we would have a horizontal tangent line at the point 0,4 right there? Because there's a hill there. And guess what these 2 points are down here? Guess what these 2 points are down here where you'd have another horizontal tangent? Negative square root of 3 comma negative 5 and what? Square root of 3 comma negative 5. You see how I identified all 3 points on the original curve where you'd have a horizontal tangent line, and I did it by using calculus, right? On paper, right? Okay. All right. Example 7. Everybody try that. Go. Try example 7. Go. People absent today, no? Just Erica? What's that? No, there was somebody when I passed off the test that didn't get the test. No, maybe it was just one. That's right. Yeah, that's right. Okay. Again, this is a typical AP problem. It's like a little puzzle, right? You got to put all the pieces together. You know all the little pieces. You just got to put them together. Typical AP question. Very few AP questions are just find the limit or find the derivative. Most of them are like this. You got to do multiple things and then put it all together. And I'd say that's the big difference between APCalc and regular calc. Regular calc you'd be doing more like just taking derivatives, maybe a few applications, but not as many as this course. So that's the main difference, if you're wondering. Plus they move a little bit slower. But they don't have to review for the AP test. Yeah, I don't think this is a calculator question. No calculator. No calculator on this one. Okay, so hopefully by now you should at least be on the right track. So let me get started. I don't want to run out of time here. Okay, so we want to find the points on this graph where the tangent line would be parallel to this line. So this is a given line. What's its slope? 2. And what do you know about parallel lines? They have the same slope. So you need to figure out where is this derivative equal to what? 2. Isn't that what you need to figure out? Yes? Okay, so what's the derivative of e to the x? E to the x, right? Okay, so since the derivative is e to the x, you can set e to the x equal to 2. And now how do you solve that equation for x? Take the what? Natural log of both sides, right? And you get what? X equals ln of 2. So the point is ln of 2 comma something. How do I get the y value? Where do I put it? This is a point where? On the original curve. So where do I put that? Into what? Into what? That? Yes? What's e to the ln of 2? Don't the e and the ln drop out, giving you 2? So there it is. Your point is ln of 2 comma 2. Ready to see what I did? Okay? Okay, last page. Okay, more typical AP questions. Shh. All of these problems will be on the next test. So if you're not studying your note packets very thoroughly and making sure you can do all these examples on a test, then obviously you're not ready for a test, right? Okay? All right, so here it goes. Determine if f of x is differentiable at 2. Well, I gave you a hint. In order to be differentiable, it first has to be what? Continuous at 2. Okay, so please write all this down, and again, write small. Okay, ready, guys? All right, so okay, we're just trying to see if it's differentiable. So before we see if it's differentiable, I first have to see if it's continuous. So the first thing you're going to do is see if it's continuous at x equals 2. And how do I do that? Well, first of all, to the left of 2, it's a parabola. That's continuous, right? To the right of 2, it's a line. That's continuous. So the only place it could not be continuous is right at 2, which is right. So all I got to do now is to see if the line and the parabola come together and meet up at 2, right? Okay, so how do I check that? How do I check if that parabola and that line meet up at 2 or not? By doing what? Plugging in the what? The 2. So plug in the 2 here and here. What do I get when I plug in the 2 on top? What do I get? 5. Now I want to know, does that equal what I get when I plug a 2 in on the bottom? What do you think? 5. Is it continuous? Yes. Okay, but just because it's continuous, does that guarantee that it's also differentiable? No, because there might be a what? A sharp turn. No, there's no hole. This eliminates the possibility of a hole or an asymptote. The function is continuous. But it doesn't mean it's automatically differentiable, because there might be a sharp turn there, right? So even if it's continuous, if there's a sharp turn there, it's not differentiable, right? So how do I check if it's differentiable or not? Well, this is what's tricky. Now I need to check if it's differentiable at x equals 2. So you can't have a sharp turn. All right? And how do I determine if it's a sharp turn or not? And if you're not taking these notes down, when you go to study these 2 or 3 weeks from now, you're not going to remember what we did. So make sure you're writing all this down. No sharp turn, guys. All right, so how do I check if there's a sharp turn? Well, this is what you need to do. You must find the piecewise derivative function. What is it? Well, what's the derivative of the top piece? What's the derivative of x squared plus 1? 2x. So that's the derivative function for x is less than 2. Notice I did not put the equal sign, because I don't know if it's what the derivative is at 2. Not yet anyway. Are you following me? So don't bring down the equal sign there. Just leave it as less than. What's the derivative of the bottom piece? In other words, what's the derivative of x plus 3, guys? 1. So that's the derivative function if x is greater than 2. All right, so are you ready? What do I need to do now to see if there's a sharp turn or not at 2? Yeah, compare the slopes. So in other words, when I plug 2 into here, what do I get for the slope? 4. When I plug 2 into here, what do I get for the slope? 1. Remember, these are the derivatives, so these are the slopes. So what do you think? From the left of 2, what are the slopes of the graph approaching? 4. From the right of 2, what are the slopes of the graph approaching? 1. If they're approaching different slopes from both sides, then that creates a sharp turn. So there's a sharp turn. So guess what? And the reason is because 4 is not equal to 1. That's the reason there's a sharp turn. And so therefore what? So f is not what? Not what? Differentiable at x equals 2. Everybody see what I did? Yes? Again, I'd say, I don't know, 2 out of every 3 years there's at least one piecewise function on the AP exam. Maybe even more often than that lately. So it's probably higher percentage than that if you look at the last 7 or 8 years of free response tests. They've been putting a lot of free response questions where you have to deal with a piecewise function. Okay? All right. So there it is. Okay, 2 more and we're done. Let's look at example 9. All right. Notice the difference between 8 and 9. Again, these are typical AP questions. This time, the first time we have to what? Determine if it's what? Differentiable. Example 9 is asking something different. This time, we want to what? Make it what? Differentiable. Different questions. Right? Got it? Okay, so here it goes. All right, so I want to find the value of A and B that will make G differentiable. Okay, well again, before we can talk about making it differentiable, we first have to make it what? Continuous. So that's the first step. So step 1 is to make it continuous. And how do I make it continuous, guys? By making what? By making what? Well, basically I got to make the y values the same, right? Yes? So I got to make that equal to that at what? 1. Okay, so here we go. So what I'm going to do is I'm going to put the 1 there and the 1 there. You got it, guys? Simplify that, and you get this. Okay, so in order to make this function continuous, I'm going to have to make 4 plus a equaling b. Now, I don't have enough information right now to find out what a and b is, but at least I have one piece of the puzzle, don't I? Okay. So I need 4 plus a to equal my b in order for it to be continuous. But just because it's continuous does not guarantee it's differentiable. So now I got to make sure it's what? Differentiable. And how do I do that? By finding again the what? Well, yeah, the piecewise derivative function, right? So here we go. What's the derivative of the top piece, guys? Remember, a and b are constants. A and b are numbers. So what's the derivative of 4x squared plus a if a is a number? It's 8x. So that's the derivative function if x is less than 1. What's the derivative of bx if b is a number or constant? B. And that's the derivative function if x is greater than 1. Right? Okay, so now what? Well, in order to be differentiable, these slopes have to be equal when x is what? 1. I need x equal to b, 8x, I should say 8x equal to b at x equals 1, right? So here we go. All right, there you go. So basically you have a system of two equations with two unknowns, right? And you can solve that system by substitution to figure out what A and B are. Well, the good news is I already have B, so the substitution will be really easy, right? So once I have B, how do I find A? Well, 4 plus A equals B, so 4 plus A equals 8, so clearly A equals what? 4. Okay. So there you go. So guys, by making b equal to 8 and a equal to 4, I will make that original function what? Continuous and differentiable. Everywhere, right? Because that's a parabola which has no sharp turns or discontinuities. That's a line which has no sharp turns or discontinuities. So all I had to worry about was to make sure it's what? Continuous and differentiable at 2. Does that make sense? Which I just did. By making what? B equal to what? 8 and a equal to what? 4. So what's my final function then? What's my final function? Well, it should be this. And then b is what? 8. Okay, so after finding your A and B, I hope you understand that. By putting them into my original function, this function will now be what? Everywhere continuous and differentiable, right? Got it? And again, why don't I have to worry about it to the left and to the right of 1? Because that's a parabola which is everywhere continuous and differentiable, and that's a line which is everywhere continuous and differentiable. And then by finding these values, I guarantee it's going to happen at 1 as well. Right? All right, last one. And this one isn't bad, guys. This is pretty easy. You ready? All right, everybody, what's the derivative? Quick, you tell me. E to the x minus 1. Okay? All right, so here we go. Watch this. Okay, so that's f of x, and this is my derivative, right? Right here. All right, so my point here, and by the way, I'm going to make the derivative darker by hitting enter out front, and that'll make the second graph darker so I can tell them apart, right? Got it? What? Oh, yeah. You know, they were supposed to get us new color ones, but... Well, no, that's okay, because I want everybody to see it in black and white, since that's what theirs is going to look like. But that's one of the reasons I wanted the color ones, because for this particular thing, you can really tell the difference in the graphs. Okay, so ready, guys? Okay, so I'm going to start by hitting Zoom Z standard, and I can change the window later if I need to. All right, so that's obviously F, and that's F prime, right? So, watch this. So F kind of looked like this, right? And then F prime looked like this, right? Right? Everybody agree? Okay, and so what do you notice, guys? This is kind of like one of those test problems on the last test where you have to match the graphs of f with the derivative graph. Okay, so what I want you to see is this. Where does this have a valley? Where does f have a valley? Right there. Isn't that where you'd have a horizontal tangent line with a slope of 0, right? And sure enough, that should be the what? The y value right there. Isn't the y value on the derivative 0? Because remember, the y values on f prime are the what? Slopes from f. Okay, what about all these slopes in here? They're all positive and they look like they're what? Increasing. So guess what? Look at all the y values here. These y values are all positive because they're above the x-axis and they are what? Increasing. You see what I mean? That the y values here, which are positive, meaning above the x-axis and increasing, give you the slopes here. You can clearly see those slopes look like they're positive and increasing. What about over here? These slopes are what? Negative, but they are what? Starting to what? Flatten out and go to what? 0? Sure enough, look at all these y values here. They're all what? Negative, and they're what? Approaching 0. You see it a little bit better now? How the y values here tell you the slopes from f?